Welcome back, dear students. This is video number 2 for Standard 10 Geometry, chapter number 3. In the previous video, we discussed tangent theorem and we discussed a proof related to that. A tangent at any point of a circle is perpendicular to the radius at the point of contact. Now let us continue with its converse. A line perpendicular to a radius at its point on the circle is a tangent to the circle. You can refer to figure 3.13. The given information over here is M is the center of a circle and segment MN is a radius. Line L is perpendicular to segment MN at point N. And what are we supposed to prove? Line L is a tangent to the circle. So let us start with the proof. We are going to do a particular construction over here, and that is take point P other than N, that means N and P both are different, and join MP. So now in triangle MNP, this particular triangle MNP, angle N, this angle is right angle. So I have MP as the hypotenuse because this is a right angle triangle, so MP is my hypotenuse. And we know that hypotenuse is always greater than the other two sides. So I can say MP is greater than segment MN. As segment MP is radius, as segment MN is the radius, point P can't be on the circle because MP is greater than MN. That means it is somewhere outside the circle. Therefore, no other point except point N of line L is on the circle. That means from line L, only one point is on the circle, that is point N. Therefore, line L intersects the circle in only one point N. And we can say that line L is a tangent to the circle. This is how we prove the converse of tangent theorem. Now let us see this particular theorem. This is called as tangent segment theorem. Tangent segments drawn from an external point to a circle are congruent. Now observe the figure given alongside. That is 3.16. We have to join AP and AQ. So in triangle PAD and triangle QAD, we have segment PA congruent to segment QA, and the reason is they are radii of the same circle. Then we have segment AD, this segment AD congruent to segment AD because that's the common side, and angle APD, so angle over here. When we join this, the angle over here, and angle QAD, angle over here, is 90 degrees. In the previous video, we discussed how this is 90 degrees with the help of tangent theorem. So now I can say that triangle PAD is congruent to triangle QAD by SSA test of congruency. And on the basis of this, I can say that DP is congruent to DQ. Reason, corresponding sides of congruent triangles. So this is tangent segment theorem. Tangent segments drawn from an external point to a circle are congruent. So now on the basis of what all we discussed just now, we have to remember this. Tangent theorem, the tangent at any point of a circle is perpendicular to the radius through the point of contact. A line perpendicular to a radius at its point on the circle is a tangent to the circle. Tangent segments drawn from an external point to a circle are congruent. Now let us move on to practice set. Practice set 3.1, question number 1. You have the question and figure for your reference. In the figure, radius of a circle with center C is 6 centimeters. Line AB is a tangent at A. Now answer the following questions. Question number 1. What is the measure of angle CAB and Y? Measure of angle, this angle, CAB and Y. The answer would be, first we need to draw CA and CB. You need to join this. So angle CAB is 90 degrees. The reason? Tangent theorem, because CA is the radius and AB is the tangent joining the radius. So the angle join made by them is 90 degrees according to tangent theorem. Question number 2. What is the distance of point C from line AB and Y? C is perpendicular, or CA is perpendicular to line AB, and CA is the radius. So distance of C from A will be 6 centimeters. Next question. You have the figure and the questions over here for reference. Here we are going to discuss the answer. So in triangle C, we have to find out distance AB. We have to find out distance AB is given to us as 6 centimeters. Find out distance BC. We have to find distance BC. So in triangle CAB, I have angle CAB as 90 degrees. This is according to tangent theorem. So now I have, according to Pythagoras theorem, CB square, which is the hypotenuse, is equal to CA square plus AB square. Over here. So CB is nothing but BC. So BC square is equal to 6 square plus 6 square, which is equal to 36 plus 36. BC square is 72. And on taking square root on both sides, what do I get? BC is equal to 6 root 2 centimeters. Therefore, distance BC is 6 root 2 centimeters. Do not forget to write the unit. Question number 4. What is the measure of angle ABC and Y? Here, angle ABC. So, in triangle ABC, I have CA is equal to CB, because this is 6 centimeters and this is also 6 centimeters. So, on the basis of this, I can say that angle ABC equal to angle ACB, because these two sides are equal. That means this triangle is an isosceles triangle. Therefore, these two angles are equal. Now, let angle ABC equal to ACB is equal to x degrees. I don't know the value, so I am going to assume it. Now, in triangle ABC, in this triangle, angle CAB, this angle, plus angle ABC, this angle, plus angle ACB, all three angles is equal to 180 degrees. The reason? Sum of all angles of a triangle is 180 degrees. So now let's substitute the values. 90 degrees plus x degrees is 180 degrees. So I have 2x is equal to 180 minus 90. From here, when I solve this, I get x degrees is equal to 45 degrees. That means measure of angle ABC is 45 degrees. In the end, we write all the answers together for all 4 sub-questions. Let's move to question number 2. In the figure given over here, O is the center of the circle. From point R, segment RM and segment Rn are tangent segments touching the circle at M and N. If OR is 10 centimeters and radius of circle is 5, then first one, what is the length of each tangent segment? So what we need to do is we need to join OM and ON. First, in triangle OMR, so over here we have OMR in this triangle. Angle OMR is 90 degrees, tangent theorem. Therefore, now by Pythagoras theorem, I can say OR square is equal to OM square plus MR square. Now, OR is given to me as 10 centimeters. So, 10 square is equal to OM is 5 square plus MR square. So, from here I get MR square is equal to 100 minus 25, which is 75. And when I take square root on both sides, I get the answer as 5 root 3 centimeters. Now, MR I can also write as RM. RM is equal to Rn. Now this is tangent segment theorem. So both my tangent segments are equal to 5 root 3 centimeters. Now next, question number 2. Sub-question 2. In the figure, what is the measure of angle MRO? MRO. I have to find this angle. So in this particular triangle, RMO, angle OMR, this angle is 90 degrees, tangent theorem. OM is 5 centimeters and OR is 10 centimeters. This is given information. From this, I can say that OM is half of OR, 5 and 10. So by looking at this, I can say that if this is half of this, that means this angle MRO is 30 degrees. The reason is converse of 30 degree, 60 degree, 90 degree triangle theorem. Similarly, I can see that this angle NRO is also 30 degrees. Similarly, I can find out this NRO also as 30. So, what is the measure of angle MRO? 30 degrees. Now, sub-question 3. What is the measure of angle MRN? The bigger angle MRN. I can say that MRN is addition of two smaller angles, MRO and NRO, these two angles. That is what I have written. MRN is equal to MRO plus NRO by using angle addition postulate. So MRN is equal to 30 plus 30, which is equal to 60 degrees. My dear students, we stop here. We will continue in the next video. Till then, have a nice day. Thank you for watching.